Okay, so let me just introduce the first speaker for the day. She's Fatima. Okay, and she'll be helping us with the topic testing phase authentication, right? And let me introduce, she's the lead consultant, QA consultant in ThoughtWorks Bangalore. Okay, and I was having a chat with her just to understand what was the most interesting thing or what was the last physical event she has given. Okay, she was saying she presented about CDP, Chrome DevTools Protocol in Selenium Conf. Hope all of you have heard about Selenium Conference. Have you? Okay, so that is Selenium conference, like our vodka, one another conference, but international. And she has given in London 2019. And then she got from there, she got an opportunity to speak in another event called DELX, Belarus in 2020 Feb, just before the Corona starting. So she was lucky. Then physical events, right? Isn't it wonderful? So for those who have not heard about this particular country, Belarus. See, it's like she was in London and then she got an opportunity to speak in Belarus. So I was just figuring out what is this Belarus. So if you have heard about the new superpower highway, like our old Silk Route, so this is the newly sanctioned one, the 1,250-mile motorway connecting China and Belarus. Okay, so she had a chance to go there and speak. So and all these are in physical events, isn't it wonderful? Okay, so this is about Fatima. So thanks, Fatima, for sharing these stuffs, interesting stuffs about you. Over to you, Fatima.
Thank you, Jyoti. I'm gonna quickly start sharing my screen,
Yeah.
and let me know once it's visible. We can get started.
It's visible.
Okay, thank you, Jyoti, for introducing me, and welcome everyone. Thank you for attending. What I'm going to talk about today is testing face authentication on mobile. Before we jump into the topic, I just want to give you an overview of what this talk is going to cover. Um, a little bit about me. I have my primary experience has mostly been in retail, and I've done a lot of coming up with automation frameworks and performance testing, security testing, and things like that, and mostly on the web apps side and backend and all of that. Recently, I got an opportunity to work with a project where we were developing a mobile app that would employ a face recognition, which would be used for authentication. So this, as you can imagine, was a very big shift for me. It was very new. It was in the mobile world. It was in the machine learning, artificial intelligence world, right? And what I intend to do is walk you through the journey that I had, that the team had, from a testing perspective. Of course, this is a very technically challenging opportunity that we had, and it also posed an equally, if not more, challenging from a testing perspective. So I'm going to talk about that. And one thing that I would like to call out is the first thing that came to my mind when I had the opportunity to work on this project was that this is going to be extremely technically challenging for for testing and automation and all of that, and it was. But what I didn't realize, which I did very very soon, was that as challenging as that was, the technical bit, the coming up with the strategy was an entirely different thing altogether. Just identifying what are the areas of quality concerns, right? And how do you tackle that, and then coming to how do you technically implement something, is what I realized was primarily needed. So what I'm going to do is I'm going to talk about the different areas that we identified for a project like this, for an application like this, and how do we go about testing something like this. And I hope this comes in handy for some of you, because I at least really had to figure out and start from the scratch and understand where do you start and how do you go about it. So that's what this talk is going to be about. I will get started with the application in itself. We'll talk about what the intent was and how it works on a higher level. We will get into details as we move on, but to start with, right? So the primary intent of this application while we were developing this was the idea was that we needed some sort of so a lot of y'all would be familiar with two-factor authentication, right? What are some two-factor authentication that we are used to? Anyone? Let's try and make this interactive. Any answers are welcome. Come on, something. When you say two-factor, let's say you're trying to log into or you're trying to transfer some money. You enter your password, but then you have to validate or authenticate yourself with something else. What is that usually?
OTP.
An OTP, right? Thank you. And an OTP could come in different ways. It could come as an SMS, it could come as an email, right? What else? Come on, you guys.
I think people are pinging in the chat.
I
So
see.
lot
Okay.
of answers are there.
Awesome. Awesome. Right. I see biometrics. I see OTP. Awesome. So a bunch of things. Face authentication, right? Thank you for that. For beating to the punch. So absolutely right, right? There is your SMSs, emails, and things like that that we've been traditionally using, but we've also reached into the era of biometrics, correct? And that's where your fingerprint comes in, your iris scan comes in, and also your face recognition, right? And this is something that we have already used for a few years. iPhone has a lot of phones, actually, even Android phones have it, right? We have that as well. So the idea of this app was exactly that, and especially at COVID times, uh, when you're thinking biometric, you also want to make it contactless, right? And what better than your face recognition, because iris scanning is not as straightforward, right? It has other limitations. So the intent of this app was to aid two-factor authentication by face recognition, and we wanted this app to be something that can be consumed by anybody who has this use case, be it banking applications or just simply an office space that wanted to validate their make sure who their employees are, right? Sometimes, like most of us, what we do is we just scan our ID cards and then get into our offices, right? So anything within that, or even in residential areas, right? The applications there are huge. So what we wanted to do is develop something that we have that would give a common app, right? A common platform where anyone can use this. So that was the business intent. Now dig, uh, digging deeper a little bit, so what we created was a headless app. We use Kotlin for this. Headless meaning this is an app that cannot be launched by itself. A parent or a consuming app has to use it or invoke it, and only then it gets launched, right? So that was the idea, that it was not meant to be a standalone app. Somebody has to invoke it, right? And by somebody, I mean a consuming app. So what happens once this headless app is invoked is obviously it'll launch a camera, and it's going to try and detect a face, and it'll try and identify if a real person is there in front of it. And how does it do that? It does a bunch of validation. So to start with, we do a validation on the client side. And how we did this was by employing an ML algorithm or a model, right? And there were a bunch of validations that we would do, but some of the key things that we would try to ensure is that, hey, first of all, is this a human being, right? And even if it is a human being, is it a real person? Is it someone who's there, or is it actually a picture, right? And or is it a video that you're seeing, right? So we had to make sure there wasn't a statue. It was a real person, and not only there was a real person, but it was a live, living, breathing person, right? And that was the kind of um, uh, responsibility that the model had of identifying that. And once it was certain that the person is a real living breathing human being, it would go ahead and send that information after capturing that face to the server side for further authentication. Now, like I said, this app was going to authenticate a person, right? And for that, we would need a list of registered users, right? And we'd have a database, and we would this database would have all the registered users with their, of course, what they look like, right? Their face, their face details, and we would do a match, and depending on if it's a match or not, we would either send a success or failure message. And now it's up to the the consuming or parent application to say, go ahead and retry, or you're locked out, or goodbye, or whatever. It's up to the consuming app. So this is where the responsibility of our application ends. Now, when I understood that this was the area, the scope of work, there were a zillion questions that came into my mind. I'm sure there are a zillion questions if you think just from purely from a testing perspective, right? How do you do this? So many hows and whats and whys. How many faces do you even test with? What would a smoke test be? How do you test a headless app? There is a machine learning algorithm, there's a model in here. How do you validate the correctness of it, right? There's so many questions that comes to mind, right? And of course, you had to think about make fraudulent transactions, because security was obviously a concern, right? Depending on the use cases, depending on the businesses that would be using these apps. And how would you even attempt to automate this? Is this even possible? There were a lot of questions that came into our mind, and the first thing that we did was we tried to categorize them into logical groups, so that we could come up with a common strategy that would tackle or acknowledge some of these questions, and we could come up with an approach to handle that. So some of the categories that we had broadly identified was, of course, the first thing was we had to identify scenarios, right? And that naturally meant coming up with corresponding data, and that could be huge in itself, right? So we that was an area that we had identified. This next thing was to validate the correctness of the face recognition bit, right? The model in itself. The next bit was the overall workability of the application across multiple devices, right? Like I said, it was a mobile device, and we were looking, this is going to be a public facing app as well. So we needed to have that sort of support, right? And not only that, we also had to test the live face recognition bit. So that was another area that we had identified. And of course, how much of this is automatable, right? So automation in itself is a different category. Security, like I said, it had huge security aspects that we had to think about it. And performance, like I said, we it had to be quick, and it had to scale at a large level, right? So these were different areas that we had identified. For this specific session, I will not be touching upon security or performance any further, because they are topics in itself. Actually, most of these are topics in itself, but I'm going to try and give as much information as I can for the other things. So let's do a deep dive, right? So the first thing is on identifying scenarios. So let me just throw it to you guys a little bit. What are some crazy scenarios that you can think of if if you were on this project and you had to go ahead and test this? What if the person is not waking or living or breathing, right? Yes. And actually, this is something that iPhones have solved. They've tried to make sure that if the person is sleeping, you do not unlock the phone, right? They have some sort of mechanism. Face is swelled, closed eyes, winked eyes. If the person is walking, or that means there could be a potential blur, right? If someone's wearing masks, sunglasses, amazing. And this is low lighting conditions. And actually, we could go on and on and on, right? So we did exactly this exercise. We tried to come up with a lot of parameters, right? Data parameters. And very soon, we had a lot of those. For example, gender, race, age, right? Different lighting conditions, different resolutions. There are various camera devices that are available out there. So how do you, account for that? Accessories, right? Glasses, turban, mask, makeup, facial hair, so on and so forth, can go on and on. Aspect ratio of the image, the nearness of the person that is there, how close they are, how far they are, the various positions or conditions of the face. Is it just part of the face? Is it a side profile? Is it front profile? Eyes opening, closing, smiling, crying, all of that. And then there was this a completely different category of images called fake images. Like I was saying earlier, is it a photograph? Is it a video? Is it like somebody who's sleeping, right? There was an entirely a different category of fake images altogether. And these are areas where we're expecting things to fail, right? The others are all areas where we want it to work for it, and we want the model to understand it correctly and recognize that these are real people, despite these various conditions. And there are areas where we want people, not people, the model to understand that this is not a real person, right? So that was an entirely different category of its own. So once we started putting all of these things together, what we got was a data set, right? And now, as you all would have already guessed, the amount of data that we got or we could come up with, or that we wanted, we didn't get it yet, was huge, right? So we needed to, now that we have identified scenarios, the next thing that we needed to do was see, uh, where do we test this, right? Where do we use this? Like, is it was obviously not possible to test this as your functional test or your end-to-end test on a mobile application, right? So where does this go? So before we go to that, a little bit on, let's understand a little bit on machine learning. What is machine learning? Quick answer, anything? Oh, I see identical twins. That's a fun one. Where we can train and test data? Yes. Anything else? An algorithm? Yes. Train machine by giving huge data tests, test data, machine that tries to learn with different data sets. Amazing. Nice. How we talk to machines, making a machine learn, right? Awesome. What machine learning is, like you all correctly said, it is a version or a branch of artificial intelligence that, excuse me, employs an algorithm which will either identify patterns or make decisions based on data, right? So data is at the very heart of machine learning. So what it does is it tries to identify patterns based on the training data that and I said training data here, right? We train the model first, or the algorithm first, help it identify or teach it, right, that these are some parameters that you need to consider. Like in our case, that this is how you identify, these are some examples of a real person and a fake person, all of that. So we train a machine learning model, right? Similarly, once that is done, we also test it. So there are two aspects that we need to do here. So what we do is, now that we have our data set, we segregate it. We segregate it into training data set and testing data set. Like I explained earlier, training is what we use for training the model, and this is where the model gets to understand, right? Just like how we learn, it also learns. This is how I identify certain things. It draws patterns and it learns how to do that. And testing data set is used to identify how well a model has learned or not. Now, it's very important that this is not the same set repeated, right? Because we have to be absolutely sure that this doesn't overlap, because then you're not getting good feedback whether how well or not your machine learning algorithm is working. So that's where our data set bit goes. Now we've identified our data set. Where do you get this from? multiple places to get this. There are a lot of open source data sets available. So some of your data parameters will be, data as per some of your data parameters will be available, for free. Some of these will also be paid, because it is a very tedious and a lot of effort to actually get this. So you may also have to pay for it, and then you still might not get data for some of your parameters, right? And you may have to start creating your own. And for something like our case, we actually had to go with an approach that employed all of these. We had to get some that was openly available, some we had to pay for, and we also started creating our own data set. And it was fun creating our own data set, but also very tedious. And that's a full-time job in itself, by the way. So now that all of that is done, we've now dealt with scenarios. How do you validate correctness of an ML algorithm? Now, I'll tell you why this is relevant. The way that we typically develop a model is that we would pick a library, we would tweak on top of it, we would have our own enhancements on it, and then we will evaluate it. Okay, we will test it, right? We'll train it, we'll test it, and then we'll evaluate or validate based on certain criteria how well it is doing. Now, these criteria could be anything. There are some commonly used criteria. In our case, we had identified these criteria as speed and accuracy, and I'll tell you why speed and accuracy was important for us. Of course, it had to be super accurate, right? Like by accuracy, what we mean is, with what level of confidence can this model predict or identify that this is a real person or not, right? Is it with 80% accuracy, or 90, or just 60, right? And we usually define that, this is the accuracy that we need, and so we evaluate different models based on accuracy. And of course, speed, because we needed this to be quick, right? You don't want to stand in front of a system and then just wait for 5 minutes until it comes and tells you that you're real or not, right? And especially for, let's say, if it's for a working space, right, as an office, during peak hours, you don't want to wait behind like 50 people to just say application tells you if you're okay to go in or not, right? So speed and accuracy were two validation criteria that we had identified for ourselves. So how does that work? So like I said, coming back to the development of a model, we picked an algorithm, we did some tweaks, and we have validated this. Now what we're going to do is, based on the results that we get, right, and how we do the analysis wouldn't just be, okay, these are how many passes or fails that we've had. As in, let's say, for example, I've given it 100 images for testing, right, and out of which 80 of them were real and 20 of them were fake, and it was correctly able to identify 70 real and 15 fakes, right? So whatever the math is, let's say 90 on 100 is correctly identified. So it's not just about the pass or fail. That is, of course, important. Then it's also how quickly it was able to arrive at that decision, right? And how accurately, what was its confidence to say that, no, this is a real person, no, this is not a real person. So this is one level of granularity. And also on the other side, we also look at what kind of data was it able to correctly identify, right? Like, for example, it was able to identify real people very quickly if there were no accessories. But let's say if the same person comes and wears glasses or a scarf or had a grow mustache or a beard, it was not able to, right? So you do analysis at that level, and then you understand that this model works well for certain things, and this is how well it works. And then you either change your tweaks or your enhancements, or you have a different algorithm altogether, and then you compare, based on with these same validation criteria. And then you finally pick a model that you are happy with, based on the testing that you've done. And and this is how you pick and you validate a particular model, right? You either accept it or reject it, and then you decide to release it, right? And you say that now this version of this model is good enough to go and integrate with the app, right? So that is on the validation of the ML bit in a very, very short manner. So, like I said, the next bit comes is now that we have the model ready and we have certain level of confidence that this model can correctly identify live people or not, right? The next bit is you integrating it with the mobile application that we have, right? The headless one that we were talking about. Now, this in itself opened up a lot of questions, right? And we had to make a lot of decisions based on those. So of course, we this was a mobile application, and given that it is public facing, we had a, a large number of devices that we needed to support, which also meant a large number of devices that we needed to test, right? So we definitely needed those devices. Now, where do you get it from? Do you get real devices? Do you go and buy them? Or do you use virtual devices or simulations, right? Real devices, of course, are the phones and tablets, what you and I use, right? Virtual devices are obviously virtual or simulations, right? They have OSs like your the particular phone version would have. It would have all those configurations, but it wouldn't be the real thing, right? So the advantage obviously was that by using a real device, this is as close you get to the end users, whereas virtual devices, well, aren't they are virtual, they are in the end of the day not real. Real devices are super expensive. Virtual devices with simulations, not so much. Given the nature of our application, we went ahead with real devices because we did have the bit of a camera being launched, and we needed to see what how that interaction is going to be. So we went ahead with real devices. Um, the next bit, again, on the choice of devices, the next question that we had to consider is, where do we get this from? Do we have a real device lab of our own? Do we maintain all of these devices by ourselves? Or do we get access to it through a cloud based service, right? And there are a lot of services that do this for you, and you all would be familiar with some of these, right? Like your browser stack and Source Labs, and there's so many options available out there. There were Cloudy that we had evaluated, and some of these are new. And the interesting bit is, especially given the nature of um, our need, it was a little different from what we traditionally used to testing, right? We had a lot of interesting conversations, and they were willing to make custom setups for us, right, that will work for you. And so if at all you're evaluating cloud services for this, you should definitely not just limit yourself to their websites, but also go ahead and talk to their representatives, because some of the options that they will provide you would be incredibly helpful. Again, one of the parameters that comes here is cost, and of course, your access to it, and then maintenance. Real devices are the cons over here are cost and maintenance, because you'll have to maintain it by yourself, whereas for cloud services it wouldn't be as expensive, and they will manage the maintenance bit for you, but then you don't have real access to it, right? By real, I mean direct access to it. The approach that we chose for our case was a hybrid approach. We decided that we'll have a limited device lab for us, and for ourselves, that we'll maintain, and a larger set of devices that we will use from the cloud services. The next thing was how to test a headless app. This was a relatively easy question for us to answer, because given that it is going to be invoked by a parent or a consuming app at all times, we decided that we will create a sample app of our own that would do exactly this. Nothing fancy. It would just, you could just launch the sample app of yours, which would in turn launch this headless app, and it would in the end give you a success or failure or whatever, right? You just needed to invoke the app. So that's the decision that we went ahead with. Of course, we also needed an automation tool, because there was some UI interactions that was coming in, right? So we needed a tool to do that, and we again, a lot of tools out there. We evaluated Espresso, UI Automator, Appium, and so many. And the choice that we went ahead with was Appium, because it just fit with the community support and the range of devices that it was supporting. So Appium was a good fit for us, right? And then the final question that we had is how, of course, we can use Appium, but how do you automate the face capture flow? So that was the next big question that we had, and an obstacle that we had to clear. So before we answer that question, let's actually talk about what the flow was, at least in our case, right? How did face authentication flow really work? So let's take a closer look. So the first thing, like I said, your sample app or your parent consumer app would launch your headless app, right? And which would in turn launch your camera. Now, once your camera gets launched, what happens here is, if you see, even when if you open your camera right now, when you see, what's going to happen is it's going to continuously feed a stream of images, right? And what it's going to do is it's going to send all of these images to the model over there. And what the model is going to do is it's going to run all of these validations that it had. Remember the client side validations that we talked about, if it's a real person or not. It's going to do that, a bunch of things that happens here, in terms of validation. And if none of these images qualify as a valid or real person, then we keep running the stream. We keep taking that as input until we're happy. And by happy, I mean if it's a real person and it's valid. Once it's valid, we get a proper image of the person. We will go ahead and send it to our backend server for authentication, where it'll do the matching with the database and give you a success or failure notification. Now, the bit that we obviously had to handle was the need for a real person to be there, right? And that, of course, was very important for our application, because without that it shouldn't work. But for us to automate, we had to somehow bypass it at the same time as well, right? Because it would be a little inconvenient to have a person in front of 1,000 devices, who would and not just one person, right? We had so many scenarios that we had to consider. So we identified that this was the only thing that we couldn't do, in an automated manner. So we had to bypass that. So the way that we did that was we introduced a test feature. And by a test feature, I mean this was a feature that would only be available in a non-production environment, right? And what this feature would do is, once you launch your camera, you will be able to see a small button, and once you click the button, it would give you access to your gallery. And then you could select a bunch of pictures, and you would be able to send it to your model. Excuse me. So what that means is, we are essentially trying to mock this bit, right, of the camera sending a stream of images. Instead, we are choosing our own set of images that we know is going to work or not. We know what are the images that are going to be live, right, that would pass or be identified as live or fake, right? So we know that we would have that loaded in our gallery, and we would just pick some of these images, and we would send it back to our model. And from here on, it's business as usual, right? It does a validation. It either gives you a go ahead, or it tells you, no, you keep giving me more images, this is not good. So this is how we tackled that bit. And the interesting thing was, this was one of the areas where, at least when I heard of it the first time, I was like, you know what, it's impossible to automate this. Like, no, we're just going to bypass this altogether, right? And what we would have lost by that is, we would not be able to test the integration of the mobile app with the model and the backend server on different devices, right? That was the thing that we would have lost had we not come up with this. Of course, the interaction of a person still had to be tested, and that would have to be done manually. But this would at least cover the compatibility bit right? And the compatibility across different services, as in the mobile application, the model, and your backend server, and also across multiple platforms, right? And that is how we handle the automation part of that. So, in conclusion, if I had to look back, there were a bunch of learnings that I had. The first thing was, it may seem overwhelming, but the first thing to do is that you identify what are the critical areas of quality concerns based on the application. Now, whatever I talked about was very, very specific to our application, right? The one that we had. Like, for example, the automation feature that we talked about. Now, that was again very specific to us. That was one way of doing it, right? And it was possible for us to do it, and we were able to do it, right? That might not be possible for you, that might not make sense for you, because of the way we knew how our application worked, and we were able to do that, right? So you have to identify what makes sense to you. And there are a lot of data parameters here, but like there's a certain category of people that you're not planning to, let's say, tackle or handle, then you don't consider that as a data parameter, right? Just because it's there doesn't mean it's important for you. Which brings me to the next point: prioritize. There were a lot of things we had to deal with, but we prioritized based on what was the immediate business need. We were live. That means we needed a way to come up with a bunch of smoke tests that would quickly tell me if this is, a good to go version or not, right? Things like that. And one thing to understand is things evolve over time. Your data set will evolve over time, your model is going to over time, your testing strategy will also evolve over time, right? And do not reinvent the wheel. There are a lot of solutions that are already thought out and that are readily, like for example, this testing feature that I said was used a few years ago for our barcode scanner, like an app that would scan barcodes for automation of that. This is what one of our colleagues had done. So had I not reached out to the community or read up about it, I would not have come across this, and I would not have had a solution to my automation problem at all, right? So do see what are some existing options that are available out there. And which bring and the next step, like I said, I thought automation would be completely impossible, right? But it wasn't. Not only did we were we able to automate the application itself, but we were able to come up with a strategy for all of the model testing and all of that in a CI/CD format, as in a pipeline. There was no CD. In a pipeline manner, right? Like once somebody checks in a model, we would have the training and the testing and all of that in that manner, and you would have your results put in a report format, and you could evaluate it. And we were able to come up with a strategy where automation could be done at that level. So it was very much possible, and it was also very interesting to do. So what I would like to conclude here is that there is a lot of technical challenges over here, and they are solvable. We saw. Uh, One thing to remember is that the role over here is very different, right? It wasn't just in automation. We were in coming up with the data set itself, right? Like if anybody who develops models will also have data and think about what kind of data. But the way that we think, the perspective that we bring, we could, if you have identified, if there are 10 parameters that are identified, we can very easily make that 15, right? That's the perspective that we bring, right? So we need to identify how we can employ those skills that we have in those different areas, right? That generally used to or haven't thought of, and it was very, very relevant and applicable, right? And with that, I would like to conclude. I can take questions for the next, I think, Jyoti, I've got another 5 minutes, I think.
Yeah, 4 minutes.
Otherwise, I would be you know what? I can just answer questions. I think I saw some questions in the chat. I can just answer them on the chat if that helps. And that, thank you. Please keep your questions coming. I will be here and happy to answer all of those questions.
You have time to take one question.
Sure. Would you like to speak, and I can take the chat question.
So for this, which library you are using? Is it in the based on the Python or something else? Means
It was
uh,
based on Python. We started with OpenCV.
OpenCV. Yeah, thanks. So for this, are you using any of the SageMaker on the to train and test? Because this could not be possible on the local system, although it is a 32 GB or something RAM. Did you set up any on the cloud for to train and test for the ratio for this finding the
Yes,
face?
yes. This, like you said, could not have been done on a local machine, right? We had gigantic machines for this.
Okay, sure. So is there any open source repo is available for this, or it is
Yes, yes.
under in the close with the
Yeah, so if you've noticed, I did not talk about, I didn't mention the app's name, right?
correct. That's why
Yeah.
I asked. Okay, no problem.
Any other questions? One more? All right, I'll take the chat questions offline. Thank you very much. This has been a nice crowd.
Thank you, Fatima. This was very informative talk on biometric validations. Okay, I will also be floating a feedback form in the chat. People, please give feedback for this talk. And if you have any additional feedback, like what else we need to do for improving this talk, you can just do all that in this link. Guys, you can see the link, access the link. Please let me know. Yes. Okay. So we'll just take a 1 minute pause while everybody fills in this feedback. So my thoughts, this is you can see the screen, right? So this is the roadmap of the biometric boom from 1916s and to 2020. So also when we speak about facial recognition system, no, so I also heard about anti-facial recognition systems. We also know that enforcement agencies, they'll be also using this. So what people do is they have these kind of privacy visors. They sort of reflect the light to disrupt the facial recognition systems. How amazing is that? So we now have to figure out how to actually overcome these kind of privacy visors in case these systems are being used for in law enforcement, etc.